Good morning students. Today we will do the reactions of ethers. Reactions of ethers. Number 1. Reaction with halogen acid. Halogen acid means H6 like HCl, HBr, HI. This reaction is the important for ether. But before doing that, I'll tell you ethers, the general formula is like this. Ethers are said to be chemically inert. I mean their reactivity is very less, and that is why you will get less number of reactions in ether. Now why ethers are chemically inert? Actually ethers are non-polar. Due to non-polar character, its reactivity is less, and the functional group of ether, it do not have any active site, and that is why their reactivity is less, and so ethers are said to be chemically inert, and that is why the reactions of ethers are very less. I mean little number of reactions shown by ethers. So reaction with halogen acid, if you consider one symmetrical ether like methoxymethane, when it reacts with hydrogen iodide HI, then the compound will break in this position. One alkyl group combine with iodine, and the your methoxy group combine with hydrogen to produce alcohol. I mean you will get CH3I, and another you will get CH3OH. I mean one haloalkane is produced and one alcohol is produced. This is methanol, this is iodomethane or methyl iodide. But when you take some unsymmetrical ether, methoxyethane, I mean both the alkyl groups are different, then who will form alcohol, who will form haloalkane? To know it, the larger size alkyl group always produce alcohol. I mean the compound will break in this position. This is smaller alkyl group, it will form the haloalkane. I mean it combines with iodine to form methyl iodide, and the larger size alkyl group, I mean CH3CH2, it produces the alcohol. This is iodomethane and this is ethanol. Similarly, this is larger size alkyl group, secondary group, and this is your methyl group, smaller one. So this one will form haloalkane, and the larger size one will produce alcohol, which is called isopropyl alcohol, or you can write propane-2-ol, IUPAC name. Similarly, this is one unsymmetrical ether which is called methoxybenzene. It is also called anisole. When it reacts with HI, this is called anisole, also common name. When it reacts with HI, methyl group combines with iodine to form iodomethane, and the benzene ring, I mean the phenoxy group, combine with OH to produce phenol. Very important reaction. But one thing you should know, in this reaction, if the alkyl group is tertiary alkyl group, in case of primary, secondary, no problem, larger size alkyl group always produce alcohol. But if the alkyl group is tertiary, then tertiary will form the haloalkane, and primary will form alcohol. I mean your product will be something different. This will happen only in case of tertiary. Iodine combines with the tertiary group, and the methyl, I mean methoxy group, combine with hydrogen to produce alcohol. This is applicable only for tertiary. That is why always you have to remember, if some tertiary group is present in your unsymmetrical ether, then tertiary group will produce the haloalkane, and a smaller one will form alcohol. So this is about the reaction with halogen acid. Now, second reaction with PCl5, phosphorus pentachloride. This is number 2 reaction. When ether, considering general formula, reacts with PCl5, then it produces directly haloalkane. 2 haloalkane you will get, and side product will be POCl3, which is called phosphonyl chloride. So main product is haloalkane. If the ether is unsymmetrical, suppose both the alkyl groups are different, that's why I have written R dash and R. When it reacts with PCl5, then also 2 haloalkane will form. One will become RCl, another will become R dash Cl, and side product will be POCl3. Here both the alkyl groups are same, that's why similar haloalkane you will get. That's why I have written twice RCl. But here, since the alkyl groups are different, 2 different haloalkane you will get, like methyl chloride, ethyl chloride, like that. Number 3 reaction with acid chloride. This is one symmetrical ether like ROR. When it reacts with ethyl chloride CH3COCl is like this, CH3COCl. This is called ethanoyl chloride. This is called acid chloride also, and this is called acyl chloride also. You can write any acetyl chloride also. You can write any one name. Then it produces one haloalkane CH3Cl, and it produces one ester like this, CH3COO CH3. This is the formula of ester. I mean the compound will break in this position. The halogen combines with methyl group CH3Cl, and this CH3CO combine with OCH3. It goes to CH3COO CH3. You will get the ester. So by using this reaction also you can prepare ester compound. Next, number 4, halogenation reaction. I mean reaction with halogen. CH3, CH2O, CH2, CH3. This is called ethoxyethane, symmetrical ether. You know, inside the functional group, this is your functional group. The first carbon is called alpha carbon, second carbon is called beta carbon. Here also this is alpha, this is called beta carbon. Similarly, next carbon is called gamma carbon according to common system. When it reacts with chlorine in dark condition, when chlorine is added with the ether, then alpha hydrogen will be replaced by your chlorine. Substitution takes place. The product will be like this. The product will be like this. Similarly, if you apply again chlorine in dark condition, another hydrogen will be replaced by chlorine. Only alpha hydrogen will be replaced one by one, not the beta hydrogen. So you should know whether the condition is dark or light. In case of light, the product will be different. In dark condition, only alpha hydrogen will be replaced by chlorine. But the same reaction, if you carry out in presence of light, then all the hydrogen will be replaced by chlorine. Suppose in presence of light, then all the hydrogen will be replaced by chlorine like this. It is called perchlorodiethyl ether. All the hydrogen will be replaced by chlorine, and if you want to balance it, you write 10Cl2, then side product you will get 10HCl. So in dark condition only alpha hydrogen replaced by chlorine, and in presence of light all the hydrogen will be replaced by chlorine. So this is about the reactions of ether. Thank you.